Hi, everyone. Good morning, good afternoon, depending on where you are. Thank you for joining today's webinar on securing Docker containers with Lifecycle Container Analysis. My name is Michelle Dufty. I'm a product marketer with Sonatype, and joining me today is Brian Fox, our Chief Technology Officer, who's going to go into more detail about our solution and a demonstration later. Before we get started, though, I just wanted to go over a few housekeeping items. This webinar is being recorded, so you will get a copy of the actual recording and the slides in an email after the webinar is over. So make sure you be on the lookout for that. And we will be taking questions at the end. So if you have any questions, please enter them in the chat or Q&A window, and we will be monitoring that throughout the session, and we'll be asking them for Brian at the end. Before I pass it over to Brian, though, I just wanted to share some kind of new exciting information we just got from a survey we conducted just a couple of weeks ago, our DevSecOps community survey for 2017. We had over 2,200, almost 2,300 respondents of that survey. And the survey information, the survey itself went over a lot of really interesting topics around security and with DevOps. But one of the things I really wanted to share with you were some questions as it related to containers. This is a little bit of a sneak peek. The actual survey results we will share with the public in about 2 weeks. So be on the lookout for the survey results then. And then we'll also be hosting a webinar on the survey and the results on April 5th. So make sure you look out for that and join if you can. But this first question we asked was, is security a top concern for you when deploying containers? And according to those almost 2,300 respondents, 88% agreed that yes, security was a concern for them. 50% strongly agreed, and almost over 38% somewhat agreed. So that may be why you're on the webinar today, to learn a little bit more about how you can secure your applications that are in those containers. But the other interesting thing we found through this survey was, of those almost 88% that said they had concerns about security in containers, only 53% had actually implemented any products to help identify vulnerable applications, OS or configurations in those containers. So it looks like there's still some work to be done, or some information most people are seeking about how they can go about securing those containers and making sure that the applications are secure and not available, insecure. Secure applications that are not secure don't allow people to get to the data within those containers. So with that, I'm going to turn it over to Brian. He's going to introduce the solution and then go into a demonstration for us.
Great. Thanks, Michelle.
So Brian, I'm going to make you presenter.
Is that coming through okay?
Yep, looks great. Thanks, Brian.
Great. So in the modern world of software development, the typical application is composed of about 80 to 90% third-party components, components that your developers themselves haven't written. So these tend to be largely open source, but they could be other third-party components that you've selected. And so this is sort of the problem space that our Lifecycle product is working in. And in this type of an environment where containers fit into it, what we're seeing is the result of those application builds are increasingly assembled, packed, and delivered inside of containers. The containers themselves are the things that get shipped from development into production. In the world of this development that we've been living in, the volume and variety of the components that go into the applications themselves can be staggering, with millions of different components that are changing, 4+ times on average every single year. And so in the container world, there's basically the same type of problem, right? Where you've got many different containers, many different base layers that you can be extending from. And so the problem of dealing with the containers is very much the same as dealing with the individual components that flow through your supply chain. And so as development and operations continue to merge, the creation of the containers are shifting left into development, right? That's the real promise, that the thing in prod is the same thing that the developers are developing against and testing against, and that there isn't environmental types of differences or, it works for me, not in production kind of thing. And so our customers have been seeking the ability to scan and manage these containers in the same way. In fact, for many of these customers, the container image itself is the final software deliverable. In other words, instead of shipping something from dev to ops that was a WAR or a zip file, they're now creating that container, right? And so in that type of a world, especially if you have an automated build pipeline, the container may be the only artifact of record that actually matters. And so what our LCA analysis is doing is working with Twistlock, who's a vendor in the Docker space that does a lot of analysis, runtime analysis, and things like that. We've partnered with them to crack open the containers, peek inside them, and be able to do application analysis when those applications themselves are bundled inside of a container. And so basically the way this will work is with Lifecycle. Now we can look inside those containers. We'll surface the intelligence with respect to the quality of those application bits that are inside the containers, and then automatically apply and manage the policies based on those results. So let's go take a look. Get this out of the way. So for the demo here, I have just a simple Docker file that I've created. You can see it extends from the latest Ubuntu base image, does an update on it, and then takes our sample application via wget and just drops it in there. And so that's the Docker image that we're going to be analyzing. The way I've done that is I've built a pipeline inside of Jenkins here, and it has a couple of stages. If we come down and take a look at the steps here, I'm doing a Docker clean build, and then I'm calling our analysis on it. And then just so I don't pollute my demo environment, at the end I'm going to go ahead and get rid of that image. And I've got two versions of this build. One of them that's set up to be basically an everyday sort of CI build that's happening in what we would call the build context, and then this other one which occurs inside of what we call a release context. So I'm going to kick those both off now, because watching builds run is not super entertaining. And while those are running in the background, we're going to go take a look at what Lifecycle does for policies, because I think many people here may not be super familiar with what I'm talking about when I say that. And so this is the management section of the IQ server, which is part of Lifecycle. This runs on-premise inside your firewall. And the demo application that I'm scanning is this demo application here. And and we have basically a couple of ways to manage the policies. We have first a hierarchical model. So this demo app is inheriting from the demo org, which ultimately inherits from what we call the root organization. Now at the root organization is where you define the types of policies and criteria that would apply sort of globally to your entire organization. In addition to the policies, which I'll dive into in a minute, we also have what we call application categories that you can create on your own. But for demo purposes, we have a couple created here that would mostly apply to legal copyright types of things, right? So there may be policies you want to create that apply to distributed applications that are different than things you use for hosting. We also see customers that have security questionnaires that their applications go through, and they put them into different levels of security, and they might use these to create custom policies against those certain types of applications. For example, applications that have PCI compliance requirements might be different than something else. Additionally, we have what we call the license threat groups, which allow you to sort of standardize the way you treat licenses. And so we ship with some out of the box, but they are completely customizable. You can choose what licenses are in each group, what they're called, what the colors are, etc. Right? So this gives you full customization around what you consider to be good or bad and how bad it actually is. Now, with those things in mind, we can take a look at the policy configuration. And you can see here out of the box, I have several different policies They tend to break down into high, medium, and low. There's a bunch of security ones that you can see. There's also license ones, and we also have the ability to do, architectural types of things with age and popularity. So if I jump into this policy configuration here, we can see that this security high policy is, I've chosen to make it a level 8 on a stack rank of 0 through 10. This particular policy is going to apply to everything, but if for some reason I wanted to apply it to only certain types of applications, I could do so here. And then we have a flexible policy editor that allows me to define the criteria for which a component would be in violation of this policy. So this one's pretty simple. If the component has a vulnerability score greater than or equal to 7, then it's a violation, right? But these are pretty flexible. And then lastly, what we have the ability to do, because Lifecycle integrates all the way across your lifecycle and provides these different contexts, of which the LCA is just a part of, what you can do is you can choose to respond differently to a violation depending on where it happens in your lifecycle. And so our Firewall product implements, on the proxy phase. So this is basically saying, if the first time a component comes into the organization, if it's in violation of the policy, do I want to allow it to continue? And with Firewall, you could stop that right at the front door. Say, no, I'm not going to let you integrate a new component that is known to be bad at the time you're integrating it. Like, that's kind of ridiculous, right? But inside of development, components go bad. New vulnerabilities just come out all the time. And so what was good yesterday might suddenly be bad tomorrow. What we're basically giving you the choice here is, do you want to do nothing, warn, or fail? And in a development environment, we tend to encourage people to make it a warning, because suddenly breaking the build on something that was fine yesterday, one, is obviously frustrating to development, but two, can actually misdirect them from the actual case, that everybody's running around trying to figure out why the build is broken when it was just fine yesterday and nobody changed anything. So by setting it as a warning, it helps reduce the hysteria around that. It makes it easier for people to consume. But if they've ignored these warnings, clearly you still don't want them to ship things. And so that's where, depending on how your pipeline is constructed, you may have different actions taken in the different release phases. And so those builds that I kicked off earlier, one of them is running in this context here, the build, and the other one is running in the context of the release. And so we should see that the results of those builds should be different. And so if we take a look at this one here, the regular scan one, we can see that one was successful. And if I come back and take a look at the release one, we should see that, in fact, this one failed. Right? So when I come down here and take a look at what actually has happened, the output is telling me, okay, the IQ server reports that the policy has failed. There's a number of problems here. So the ultimate action was a failure, which was then reported up to Jenkins, right? So now if I want to go take a look at what was actually found, I can click on this link here, and this is giving me a detailed report of the actual application, right? So this summary page is giving me sort of a high-level visualization of where the security issues might lie, what the license breakdown was. This next view is giving me a detailed breakdown of the compliance with policy, right? So that security high policy that we created and I set to fail, that was the one that actually caused this to fail. So I could see that there are 3 components in violation of that. Now, if I drill into this a little bit, I can see that, this is the version that I'm currently using. And at a glance, I can see that the next handful of minor versions are also vulnerable, but that this one here, this 2.1.4, seems to be pretty popular and doesn't have any vulnerabilities, right? And I can look at the information about each of these different versions. So this is not only telling me that I have a problem, but it's guiding me towards making a better choice using all of the available information. Now, if I want to understand exactly what's going on with the vulnerabilities, I can do so here. And this one is an interesting one. What happens when we do our data analysis is that we take the feeds from many different places, including feeds that we generate on our own, and we pass them off to a security team who ultimately is tracing down the root cause, right? So every time there's a fix introduced and one of these things is reported, we take a look at what actually was fixed, and then look at the code history back to find when it was actually introduced. And so we set our own version ranges on the root cause, like you could see here. This is what this root cause is telling me, that this particular class from version 2.1 to 2.14 has the code in it that is known to be vulnerable. We record those fingerprints, and we found it in this jar here. And so this allows us to very accurately report on what exact versions have the problems in them. Maybe surprisingly, maybe not, we find oftentimes that the data in the NVD is incorrect. It tends not to get updated, and we find cases, sometimes people go back and re-release something and forget to apply the patch or whatever. The way we've structured our stuff, we will always trap that and report on any of those things that suddenly became vulnerable. In addition to correcting the information, we often provide extended information. So I have a couple of cases here that we could take a look at. This one here, the description at the top is what you would find if you go to the NVD, right? So it just basically gives a very superficial description of what's going on, which from a development perspective may or may not be sufficient to really understand this. And so all the information below this is stuff that our security team has created with custom advice and explanation. So we've rewritten an explanation to make it really easy from a developer to understand what does this mean? What actually happens? Why is this a problem? And how can I know what's happening, right? So here we give some examples of how you might detect what's going on. And we provide different recommendations depending on what it is. We find the root advisories that we think are most relevant. The NVD reports will often have dozens of them, and it's hard for you to figure out which ones actually are worth reading, and so we provide that. And if there are any links to Metasploits, we will include those as well. And so this extra level of information is pretty key to make this stuff really actionable by your developers. Here's another example with a pretty good explanation. This one also includes some code for your developers to be able to test if they're actually exploitable to this or not. Right, and so in this case, the recommendation is talking about the fact that the component at this coordinate is deprecated and no longer maintained, but we point you to where the new set of coordinates are, where you can find an updated patched version of this. Right, so we're not just providing publicly available information. We're enhancing it and correcting it and making it truly actionable for developers. So that's what's happening with the security information. We also provide the license breakdowns. And so this view here is giving you basically a bill of materials for your entire application, so you can understand where you might have license issues. And again, this is clickable, and you can drill into it as well, right? So that's that level of information. In addition, so the lifecycle report right now is focused on mostly the application analysis. That's what Lifecycle has always done. The LCA is, again, taking that and extending that into being able to analyze inside of containers, which are now often the application blocks of record. And so this first version, we're focused solely on the application content, but if you're interested in any of the information that's going on inside of, let's say, the operating system or other things that are not covered in our application analysis, the twist lock part of that you get with this also covers that, right? So we could see, if I want to look at what's going on with that latest Ubuntu image, I can do so here, and this provides you, similar information about what's going on with those particular components, right? So taken together, you basically get the best of both worlds. You get the ability to understand what's going on within my applications and the other things that are inside the container, and you also get the ability to understand what's going on from the let's say, the operating system part of the container as well. And so that, in a nutshell, is LCA. So do we have any questions, any clarifications I can provide?
Yeah, thank you, Brian. And just a reminder, if you do have questions, please enter them in the chat or the Q&A window, and we'll monitor them. So one of the first questions, how do the vulnerabilities found compare to, for example, the scan that Docker Hub does?
Right, so the Docker Hub scan, I don't believe they have a security team that's doing the custom and expansion and the information that I showed. right? So I think you're going to find similar to the publicly available information about the containers. But most importantly, that's only going to tell you about what's in Docker Hub, right? So it's not going to help you with your own images, your own containers. It's only going to show you what they know about that base image. So this, with the combination of the Twistlock information and the stuff that they provide and our enhanced security and license analysis, you definitely supersede what you would get just out of the hub.
Okay, great. Are you analyzing all of the container or just certain parts?
It's the whole container, so we're getting all of the fingerprints of all of the files inside of the image from the Twistlock scanner, and so they're doing analysis on things installed by the application packages and the operating system itself, and then we're taking all of those fingerprints and trying to understand what application components are in there and building our assessment based on that.
Okay. When you accept the risk of a vulnerability, is it possible to accept that risk in the same component across all projects and pipelines?
Yeah, so we're talking about waivers here, right? So if we take a look at one of these ones here, and it's a policy violation, if, for example, there was an instance where this particular one could have been fixed by changing a insecure by default type of config, I have a couple of ways of dealing with that. I could mark this as not applicable, or depending on the policy, I also could just accept the risk of the policy by doing what we call a waiver. And waivers can be applied in different contexts depending on what your permissions are. So you can see here, I can do it for this app, for my organization, or my whole root organization because I'm logged in as admin. And I can also do it for an individual component or all components, right? So this gives me the flexibility to sort of accept certain issues in my context.
Okay. Another question. Are you looking only to the applications and third parties installed from standard package managers, or as well to compiled applications?
Yeah, as I mentioned before, the Twistlock part is looking at the installed applications from the package managers, but our analysis just literally takes the fingerprints for everything and figures out what's in there. We don't care how it got there. And like I showed in the beginning, this was dropped in there just with wget, right? And so the bulk of the things that I was analyzing was inside the zip file. Has nothing to do with what was actually installed in the container. It's what's present in the container.
Okay. If new vulnerabilities are discovered, will existing images in our repositories be identified, or does this only apply at build upload time?
Right. So one of the core capabilities of Lifecycle is basically you can configure it such that the last bill of materials that goes through whatever phase you define, so say the release phase in this instance, can be configured to be continuously monitored, right? And so what happens there is we remember the fingerprints, remember the bill of materials that we last saw, and every day we will do an analysis to look for new data that may have changed. And if that produces a new violation, then that would trigger a new warning, and you can configure that here. For example, on a security one, you may want to email the security team, right? On a legal one, you might want to notify a different set of individuals. And so yes, we have the ability to continuously monitor applications even if they're not currently being built.
Okay, and then there are a few questions around licensing for Twistlock. Does it come with a Twistlock license, or would you need to procure that separately? Yes, the answer is it is Lifecycle Container Analysis is a separate product and solution from Lifecycle, so there is a cost to that. If you are interested in pricing or want to learn a little bit more, we can definitely get with you offline and share that information with you. But it looks like that's it for the questions, unless anyone wants to enter any right now. Otherwise, I guess, Brian, you want to go to the last slide? All right. Okay. Well, I just want to thank everyone for attending today. Thank you, Brian, so much for the information and the demonstration. If you do have any more information, you can always contact us from our website, or to learn more about the Lifecycle Container Analysis solution, you can go to sonatype.com/containers and learn more about that. So thank you again for attending, and be on the lookout for the recording and the slides of this presentation in the next couple of days. Thanks again. Thanks, Brian.